So welcome to the first video of the Crystallized series. So this is the first video, and right now I just came from revising maths. Yesterday was the maths bridge course, so I was revising that, and I won't take much of your time. I'll just say what are we going to do. So in this, I'm going to basically explain my physics notes to you. Okay, so basically the physics notes I have made that I revise, it's only been 30 days for me being in class 11, and in this 30 days what I understand, and actually we'll pick up the first chapter and we'll break it down into small 30 minutes videos, and we are going to complete the whole chapter in damn in detail. That's from where the name is derived, the crystallized series. So I'm going to take out my notes from in front of you and we're going to start. So this is my what do you call maths copy, so I'll keep that. And so here you go. I'll just actually see the topics, and so that I don't miss out anything. And mainly it would be me explaining. I'll give you a visual explanations as well, and I'll give you visual explanations as well in between, so that you understand better. So how about we start? So the first thing, when you will open your physics book or you'll start your lecture in any coaching, the first chapter in physics is units and dimensions, as you know. So and the physical world is like, we won't I won't even be making a video on that because I don't think that's relevant for Jay. But still, let's start this video by our aim over here, aim IIT Delhi. Okay? So yeah, and physical quantities. Okay, let's start with units and dimensions. So the first topic in units and dimension is physical quantities. Now what the hell are physical quantities? Physical quantities are the quantities that you can measure using a physical instrument. Physical quantities are the quantities you can measure using a physical instrument. Okay, like for example, time, mass, temperature, anything like that, even momentum. Okay, so these things. Now how can you classify physical quantities? So physical quantities can be classified in two ways. One is on the basis of direction and one is on the basis of dependency. Okay, so on the basis of direction, on the basis of direction, physical quantities can be divided on the based on direction into two parts. One is scalar and one is vector. So when we talk about scalar, so in scalar there's magnitude, but there's no direction, or yes, I mean it doesn't depend on direction. If you'll write a proper definition, then I guess you should write the definition for scalar as if that scalar is a quantity that has only magnitude in it, and it does not depend on direction. And one of the major things which is not written in the book of class 9th or 10th is that scalar depends on, I mean, the main difference between scalar and vector is the difference in addition. So in scalar we directly add, I mean, like for example, let's take an example for mass. Okay, imagine we have a bag of rice. Okay, so when we take an amount of rice, let's assume the bag has 5 kgs, and we take another 5 kgs and we add it from the right. Okay, so it would be 10 kgs. But if we take that 5 kgs and add it from the left, it will still be 10 kgs. So directly addition. And same thing for vector, but it's literally the inverse. Okay, so when we take vector, it depends on magnitude as well as direction. Okay, so let's take force. Okay, so imagine we have a box right over here. Wait a second, imagine this is a box. Okay, and if I put pressure from over here, and this is about 2 newtons. Okay, and this box would be moving here. But if I would place another over here, then it would normally add as we add in mass. Okay, so if this is also 2 newton, so the total force on the object would be 4 newton. Okay, but if we take the force which is applied over here at present and place in the opposite direction, then the force on the body will be 0 newton. So that's the major difference between vector and scalar. So the difference is between direction and addition. The thing is that the main thing is addition. Addition word is pretty specific. It's like a keyword. Okay. So the difference between addition. So uh, crux is that scalar depends on magnitude, while vector depends on magnitude with the direction. And one more thing is that vector depends on the law of vector algebra. Okay, law of vector algebra. That's a concept we'll what do you call that see through in the what do you call coming up classes. Now, based on dependency. Okay, uh, based on dependency. So based on dependency is like on what parameters are the physical quantities based on. So let's say there are two, means on the base of dependency there are two fundamental variations of physical quantities. One is fundamental physical quantity, while the other is derived physical quantities. Now, what are fundamental physical quantities? Because we need to understand fundamental physical quantities before we understand derived physical quantities. So let's take fundamental physical quantities. Fundamental physical quantities are the physical quantities which are set by the scientists. Why did scientists set this? So physical quantities were set by the scientists to what do you call derive other physical quantities. What does this mean? That you can derive every other freaking physical quantities with just this set of seven physical quantities. Okay, so let's talk about these fundamental physical quantities. So as I mentioned, there are seven in numbers. What are they? Time, current, temperature, length, mass, and what do you call amount of substance and luminous intensity. Did I miss anything? Please comment. Okay, let me repeat again: mass, time, temperature, uh, amount of substance and luminous intensity. Okay, so yes, and let's say that derived physical quantities. So derived physical quantities are all of the other quantities, be it momentum, force, other things like, for example, velocity, speed, these things, and all the other quantities leaving these seven. Which seven? So I guess you should repeat this, because then only you'll be able to remember. Sometimes even I forget if I'm in a hurry. Okay, because it is the initial stages of our preparation, so we should repeat this. So time, current, temperature, time, current, temperature, then time, length, sorry, then length and mass. Okay, and then amount of substance and luminous intensity. Okay, fine. And now fundamental or base physical quantities we define. Fundamental physical quantities are also called base physical quantities. Okay, so they are completely independent. You can define this in other physical quantities, but it is set by the scientists. Okay, so this is the crux. Every other physical quantity other than fundamental physical quantity is derived physical quantities. Okay, so let's go to the second segment. So derived physical quantities. What are derived physical quantities? So derived physical quantities, as I mentioned, they are the physical quantities other than fundamental physical quantities. Now, let's talk about the units of fundamental physical quantities and their dimensions. So means the representation of their dimension. So let's take the first fundamental physical quantity as mass. So mass is defined as in dimension as m, big M. I mean, yes, and its unit is kilogram. As a unit mainly, we use kilogram. Means if anywhere in a numerical you get in gram or something else, you need to convert it into kg. Okay? And let's take the second one, which is length. So length is meter. Okay, so it's m and its dimension is l. Okay, same for time. Time is measured in seconds and its dimension is t. Temperature is Kelvin, K, and is measured in K. Okay, its dimension is also K. So let's talk about other physical quantities. So temperature we talked about, time we talked about, length we talked about, and we talked about mass. So current is measured in ampere and is represented in dimensions, as well as ampere is written A as A, capital A. Okay, luminous intensity is measured in candela, CED. Okay, as a representation, and the amount of substance is measured in mole, MOL, as a dimension, and while what do you call it? MOL is the unit. So yes, Now let's talk about some derived quantities. Means this is the initial. We'll talk in a little while about many physical quantities. Okay. So this video is going to be 30 minutes. So we'll see till where can we pull this video to. So let's talk about some derived physical quantities. So let's talk about speed. Okay. Speed is distance by time. Okay. So I'll pick up one more new topic so that your what you call brains can be what you call means you can understand the topic which we left long before, which was the difference between distance and displacement. So I'll tell you that first. Let's complete speed. So distance by time. Okay. Distance by time. So let's say that we don't know, we know time is measured in seconds. It's what you call dimension is t. So if someone tells you to take out the dimension of speed, so let's say speed. Okay, you take speed. Okay, and now you have to take out the dimension of it. So you know speed is distance by time, but you don't know the what you call the dimension of distance. So let's say i tell that I tell you that measure a rod of 5, or leave it, measure the distance from Kolkata to Delhi. Okay, so you might say it's something something kilometer. What the hell was kilometer? Kilometer was length, meter was length. So you get it that the distance is actually length. So it will be L by T. Here one more new topic comes in there about maths. Means it's an integrated version of maths. So let's say we take a variable a. Wait a second. Okay. So let's say we take a variable as a. Okay. So if a is 1 by a, okay, a is normally written as 1 by a, then you can also write this as a to the power minus 1. Okay, so this way, when we have over here, when we have L by T, so we can also write this as LT minus 1. Can't we write this? Wait, I'll write here for you. LT minus 1. Okay, so we can write this. So this is your dimension. And don't forget, as in school, they could cut your marks in boards and in school. So you should use this bracket. This is a box bracket, I call it always. So this bracket, you should always use it when you're representing your dimensions. So yes. And well, let's talk about other physical quantities. So let's say velocity. Okay, velocity is displacement by time. You might ask, what is displacement? So I'll tell you the basic difference between distance and displacement. So imagine we have a triangle. Okay, or leave it. Why do we need a triangle? We need a square or cuboid, a rectangle, whatever this is. Okay? It's a rectangle, obviously. Okay, so let's say that Raju Raju travels from this point to here, then to here, and then to here, and then to sorry. Yes, Raju travels this much. Okay, so if Raju travels from A to B, okay, let's call this C and let's call this D. This is about 5 meter. This is about 6, and this is about 5. Okay, so the total distance traveled by Raju is 5. Okay, the total is 5 plus another 5 was this plus 6, which is 16 meters. Okay, 16 meters. This is Raju's distance. If we talk about displacement, then that comes up to, means the simple thing in displacement is that you need to just connect the initial and final point. Okay, so it's nothing. Even if you have a freaking circle, and this point is from where the person started and this point is from where the person stopped, so this will be called as the distance, but this will be called as the displacement. Just connect it with a straight line. And if, let's talk about this displacement first. So this displacement would be this. So if this is 6, so let's call this 6. Okay, so the displacement would directly be 6 meters. It's not that complex. So let's say imagine Rahul, means the initial character we took, only travel to point C. Okay, so the display distance would be 5 plus 6, which is 11, but the displacement would directly be A to C, which is a diagonal. Okay, which is a diagonal. So you can take out the diagonal of a cuboid. Okay, so that would be the displacement. Okay, so that's pretty easy topic. Now I'll give you the definition. So the definition for distance is the total this means total length traveled. Okay, and the amount for the displacement is not the shortest length. This is a pretty big method which other schools teach, or majority of the schools teach, but the actual definition for displacement is the efficient distance between the 2 points, or the direct distance between the 2 points. If you need to write this, it would be uh, in- it would be 2 points connecting each other directly or with a straight line. So yes, if you would be writing this as a definition, so displacement would be the shortest distance from A to B. Okay, this would be the definition if you need to write it. But I guess if you understand the concept, it will be pretty damn easy. So let's talk about acceleration. Now we talked about velocity. Velocity has the same dimensions, means displacement by time, as displacement is the same as distance. Okay, displacement is the same as distance. So what you call it is measure, sorry, not displacement is not same as distance. So displacement has the same unit as distance, as it is measured in meters. So it would be a length. Okay, length by time, we just talked about it, lt minus 1. So that would be the dimensions for velocity. Now let's talk about acceleration. You must have I guess studied it in class 9th, that acceleration is just velocity by time, isn't it? It is velocity by time. So let's take velocity. Velocity, what was our dimension for velocity? Lt minus 1. And what if we divided by time? So this is also a concept. I guess it's a math concept, but yeah, I can teach you. So let's say if Lt minus 1, okay, and this is t. So let's say this comes over here. What does this become? This becomes t minus 1, and this is obviously multiplication. Didn't you study, I guess, in class 10th, that if the base value or the number value is same, like for example a to the power 1 is multiplied with a to the power 1, okay, so the powers will get added, and the numerator means it will be equals to the main body part to the power 1 plus 1, means the initial plus this, obviously. So if we use this same concept right over here, the final dimension will be lt minus 2. Okay, so this is the dimension for acceleration. I guess you understand, and please put your reviews in the comments. So yes, this is acceleration. Now, there's a concept of supplementary quantities. What were supplementary quantities? So there are some what you call some derived quantities which had more quantities. Like the two supplementary quantities are plane angle and solid angle. So some quantities depend on solid angle and plane angle. What is solid angle? So sorry, what is plane angle? So plane angle is just the basic angle you have actually seen. The, like for example, you have a circle. I know it's not a proper circle, but please manage. So this is an angle. Okay, and this angle is called a plane angle. As you see, this is a 2D circle, and the angle in a 2D circle sector, okay, this is called what you call angle. Okay, plane angle. A solid angle, whereas, is a spherical. Like for example, I draw a sphere. I can't draw a proper sphere, but yeah, I'll try. So let's say this is a sphere. Okay, so let's say this is the center of the sphere, and when we draw an angle over here, it would be of conical shape, like an ice cream cone. So this point, this angle would be like 3D. Okay, like if I would suggest you, wait a second. Okay, and this part right over there, this is extra information. This part is called an apex. How can you remember? How can you remember this? So there was a topic in, I guess, biology in class, I guess, ninth. Okay, so there was there it was mentioned that apex predators, do you remember, apex predators were the predators on the top of the pyramid, food pyramid. So you can remember this is the top and this point is pointy. Okay? In the same way, when you remember this, this also looks like a pyramid. So the topmost part of the pyramid, or the conical for us over here, is called an apex. Okay, so let's get back to the our what do you call it, main topic. So what is a solid angle? So this angle is solid angle. So for your better understanding, let's take a 3D what do you call view. So imagine this is a page. This is my rough copy. I mean, the copies I make. I guess you have eaten a softy cone or something like that. This the conical ice creams which come in shop, because I like ice creams. You also must, or if you are from our side, means Bihar and all, so you must have eaten bhunja. What you call over here means some type of savory snacks or something like that. So you must have noticed it comes in a conical shape like that. Okay, and let's say a conical shape like that. This is the proper angle if you see in a circular, means in a spherical way. Okay, so this is connected to the center, and this part over here, as you see, if I enlarge it a bit, so inside it makes an ice cream type thing. Okay, so that part over here, inside over here, almost that angle which is made, that is a solid angle. Okay, so we are done with solid angle. Let's talk about units. Okay, units. What is the main importance of units? So let's say there is a unit of the same species. Now, what do I mean by same species? For example, the units of a physical quantities. There can be multiple units of physical quantities. You might say how. So I'll give you the answer for how. So let's say I measure a rod in meters. Okay, you might say centimeters. You might give the let's say 5 meters. I measure the rod in 5 meters. You say no, that's 500 centimeter. I say, and then I'll go to millimeter, then you will go to micrometer, then we'll go to picometer. Leave that calculation. Okay, so in the same way, there are multiple units. There are multiple units for a physical quantities. That's why I say species, because let's integrate some bio also. So let's say quantities for what you call physical quantities. So let's say a rod is what you call it, 500 meter. Okay, sorry, 500 centimeter. So I'll say that it's 5 meter. Okay, and here one more concept comes. This is also a major concept, means this chapter is just the basics for you. Means if you, how good you understand this chapter means how good you understand the rest of the chapters, because mainly these quantities are used. So let's say 5 meter. Okay, right, and 500 centimeter. Okay, let's you I'm going to use some terminologies over here. Let's take this as n1, means number 1, and let's take this as u1, unit 1, this as n2, and this as u2. Okay, so this is actually a formula type unit. So let's say that uh, the unit says that if 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 u1 is greater than u2. Okay, if u1 is greater than u2, because obviously meter is greater than centimeter, we all know that. If u1 is greater than u2, then this would be smaller than this, which is obviously true. Isn't that right? So this is just I guess terminology. Even I don't know where it would come in handy, but as my teacher told that it will come in handy, so you should know this. Okay? So right about that, this is the terminology. So why do we need unit? The basic needs for units are actually why do we actually need unit? We actually need unit to differentiate between the magnitude of the physical quantities. I mean, like for example, if I directly say, oh, Delhi to here is 5 kilometers, your mind makes a perception of 5 kilometers this long distance. If I say it is just 5 meters away from here, you'll just say it's like 20 to 30 steps away from here. So you get a reference, like an image is created in front of you. So that's the what you call main importance or the significance of units, which we generally ignore. Okay, you need to love a subject to, I mean, derive these things out of the subject. So let's leave that for a second. Okay, so units are actually the standard reference value of any physical quantity. Okay, so it's a fixed number or a fixed quantity of a physical quantity from which you can represent it to the whole world. Means if even I say kgs, okay, anywhere in the world, be it China, Japan, Russia, or any place, even North Korea, okay, might be they have their own units, but still they would use a calculator and they would calculate the hour unit in their unit, and they would at least understand the exact measurement I am doing right over here. Okay? And I guess I'll talk about some unit system in like right now in some time. Okay? In that you will understand how many major unit systems are there in the world and how they are used. So that's the topic of unit conversion right now. We are going to initiate into it in a bit. So let's see. So let's take unit. Your means conversions. Sorry, unit conversions. Okay. So MKS system. What the hell is MKS system? So let me just give you a brief understanding so that we'll not dive into the void. And so let's say that the world was divided in many areas. So example, the upper Europe, the US, or other areas. So Germany, let's take the main India over Germany, and over here is the Britain. Okay, so in India, you might have noticed whenever we go to the shop, a clothes shop, let's take a clothes shop and a sweet shop. Okay, we use kilograms. Okay, we use kilograms. जैसे if I say in हिंदी, तो तुम बोलते हो कि भैया आधा केजी या फिर 1 केजी 2.5 केजी, you use these terminologies, right? You use these terminologies, आधा केजी, 1 केजी, 2.5 केजी. So these terminologies are in kgs, kilogram. Okay, so kgs. Okay, and you go to a clothes shop, meters. वह 1 मीटर वो दीजिए, क्या बोलते हैं, कपड़ा, वह 1 मीटर क्या रस्सी दीजिए. And so you say like that. Okay, so we use meter in India, so our system of units is MKS system. MKS system, meter kilogram second system. Now let's go to Germany. Okay, Germany was here, so let's go to Germany. Germany uses CGS system. CGS, centimeter gram second. It The calculation does become a bit complex in CGS system. Means you need long numbers. So MKS system has been adopted by most of the European countries. No one will ask you this. Anyways, CGS system, centimeter gram second. FPS system, used in Britain. CGS system, I explained you. FPS is separate, used in Britain. Britain uses. Have you heard? Have you measured yourself in foots? This term F. Let me say P. Have you went to a bakery and asked, "Give me 5 pounds of cake. Give me 2 pounder cake." Yes, cake is measured in pounds, which is a unit of Britain. Okay, so pounds, foots, and seconds is like common for everything. No units is without seconds. So the hassle is that most of the quantities are like by seconds. Okay, by t time. Okay, so the hassle is that when something is division, it's a bit brain hacking to cut this off. Otherwise, the thing comes in a bit of fractionish type of thing. So the thing is, everywhere they use seconds. So like most of the things like velocity, acceleration, you don't need to what you call bang your head on the table, and it easily you can convert it into different values. Okay, that's the significance. So I guess you understand it. If you'll what you call revise this, even if you hear this lecture, means what I'm recording right now, many times, or like 2 to 3 times, minimum 2 to 3 times, you'll remember all the quantities, I'm damn sure. And please give a review so that I know. Okay, and let's see some questions actually. uh, so the question states, a particle of a mass 10 kg is moving with a velocity of 20 meters per second. 20 meters per second. What is the velocity? 20 meters per second. I'll just say the data. And what's the mass? 10 kg. Okay. Momentum in MKS system and momentum in CGS system. We need to find the momentum in MKS system and in CGS system. Notice that uh, the initial units, I mean, the mass is given in kg. MKS system, K, kg, K, kg. Yes. They are same. And meter 20 meters per second is the velocity. Wow. MK system is given directly. Take out the momentum. What's the formula of momentum? Type in the comments. Type into comments. Now, momentum, mass into velocity. Mass into velocity, mv. Okay? Mv. Okay, so momentum, just multiply the two. What will be the answer? I guess 200 kilometers, sorry, 200 kilogram meters by seconds. That should be the answer. Okay? If in CGS system, so I'll give you an illustration. This makes it pretty easy to solve. I guess anyone over here is just finding from basics, so I'll just teach you in basics. So imagine what was r. So it was 200 kilograms. Wait a second, this would be hard to solve otherwise. 200 kilograms meter per second, wasn't it this? So if it was this, if we need to convert, just convert this, okay, into CGS system. CGS, centimeter, gram. So let's convert this into gram. So in 1 kilometer, how many kilogram, how many grams comes? So about 1,000. So this would be 1,000. So the number over here will be multiplied with 1,000, and then this would be converted into centimeter, sorry, kilograms. Okay. And what about meter? If we need to convert this into centimeter, then we need to multiply this, means 1 meter is about 100 centimeters. Okay, so we need to multiply this by 100, then it would be centimeter, means this equals to that. Okay, so totally just count the zeros: 1 2 3 4 5. Okay, 5. So it would be 200 multiply 10 to the power 5. This would be the answer, I guess. Let's see the answer. And yes, that is the answer. Okay. So, and one more trick, if you don't mind, remove this 200, put 2, and then 200, add two zeros right over here. Just add 2 in the power, 10 to the power 7. It makes the calculation pretty easy. This would be your value. Okay, so yes, that was pretty easy. Okay, in the same way, never forget the square. Okay, in this some people forget the square. I'll give you an example for square as well right now. So like let's take something with a square. Wait a second. I guess let's take a question. The question states that density of oil. Okay, oil which we use for cooking, or which you apply in your hair. So oil, I don't apply, obviously. I don't know that special. So oil is measure, the density is measured in, I guess, rho. Yes, what we measured our that resistivity. In the same unit we measure what you call density. So the density of an oil is given as rho. Okay, and it is equals to 6 uh, kilogram per meter. Okay, sorry, per meter cube. Okay, that's the formula for density, as it is volume. Okay, so what is given to us? It is 6 kilogram meter cube. Okay, cube. We need to convert this into CGS system. So kilogram will be converted into gram. GM, which is about 1,000. So this would be 1,000. Remember, this is a cube. So I'll teach you this. 3 is over here. Let's say meter cube. First convert meter into centimeter. So put a bracket right over here. So meter is about 100 centimeter. Okay. So 100 centimeter. Now you take the cube in. What will be the cube? So the answer for this would be in cm cube. Okay. And how many zeros would come in one? So if this is cubed, there would be 1 and 6 zeros. 1, 2, 3, 4, 5, 6. I was out of space. Okay, so this would be our value. So let's say this was 1,000 right over here. Okay, so this one, 3 zeros gone. This would be our, what would be multiplied over here. Okay, and directly let's put in our powers. So this would be 6 multiply 10 to the power 10 to the power 1, 2, 3. Three zeros. Three zeros. This will be grams gm by centimeter cube. This would be the answer. I'm sorry if this looks messy, but I guess you understand. Okay, and so that was all about anything. Okay, so now let's pick up one more topic, and after then we'll end this. We'll not pull the video much more longer. Next we'll do in part 2. So let's take, I guess, two more topics. So SI unit system, do you know what is SI unit system? SI unit system is like the system, like I told you. MK system is pretty easy to handle and is less calculative. So generally the world has taken it into what you call adapted into it because it's not that complex. So yes, so MK system is provided to every nation and it has become the SI unit. Okay, uh, SI unit system is four units or four physical quantities with two supplementary quantities. What were the two supplementary quantities? I guess you know, I mentioned it. Okay? Units are added like example force, Newton, and energy in joule. I mean the units were added for force and energy, which is joules and newtons. Okay? So this was an additional to make it SI, because everyone measures. How much will you write like for force MA? How much will you write the I mean dimensions of MA everywhere? So that's why they introduced newtons for force, so that the calculation is made simple and it doesn't confuse new readers actually, the main thing for this. So we talked about dimensions. The thing about the way in which I made my notes is that the dimension is like clear to you before, and after that I've introduced dimensions in it. So in the next I guess in the next class we'll what do you call uh, break down many dimensions. I mean, many various dimensions. In this, we'll just break down, I guess, 7 to 8. Okay, so let's take. You know what's the dimension? Okay, I'll give you a task. The dimensions of mass, length, time, temperature, current, luminous intensity, and amount of substance. Just these dimensions separately. Just write it down in the comments and like or whatever. Comment only if you are what do you call serious what do you call viewer. Okay, I don't want anybody like useless or something like that who is not serious in their studies seeing my videos and all. Okay, because I'm also putting damn in effort right over here. So yeah, obviously. And so yes, let's talk about area. Have you heard? Oh yes, I just recorded that video, and you might be asking why just cut and shift from literally academic to normal talk. So I recorded the whole video to about 1 hour. Okay, I had a clock next to me, so it was 1 hour, and the recording stopped in between. I don't know for what apparent reason. So and the episode is about 46 minutes. So yeah, our time was also expanding a lot. So the I discussed some dimensions in the part which was not recorded. So we'll what do you call discuss that part in the next video in a much faster way, so I don't waste your time. So thank you. Like, comment if you want, if you feel this video helped you or something, and comment what should I improve. Okay? Anything, even the lighting and all. Anything, just comment and leave a review. Okay? Thank you very much.